Now, as we get into Chapter 11, we're going to talk about three sections. It's going to be 11.2, 3, and 6. This first section, you're going to notice there's actually 5 different objectives that we're going to address. These 5 right here. And what it deals with is looking at the standard normal curve. We're going to find area under the curve, or we're going to find probabilities. It means the same thing. And then you're going to actually sketch the curve in scenarios. So let me just show you what we're getting into here. This is called the standard normal curve, and it's something, again, we use for probability theory. You're going to see these numbers here on the bottom. These are what they call z-scores, which is a review of something that we did in first semester. So let's just get started with the notes and talk about what this curve is, how do you find the area underneath it, and that's really what section 11.2 is about. Okay, so here we go. Finding probabilities using the standard normal distribution. The standard normal distribution is a distribution of z-scores. And if you remember from first semester, z-score is, you're going to take x minus x bar over s, or standard deviation. So for example, let me say that the class average on this last test maybe was 32 points. The standard deviation, most people deviated 5 points, either high or low from the mean. So you could compute your own z-score. If your test score was, let's say, 36, you would take your z-score is your score, which is x, of 36, minus 32, all over 5, and your z-score for this case would be 4/5. So you are going to be computing some z-scores. And what the z-score does is this. It says how many standard deviations a piece of data is from the mean. So in this case, if I scored a 36 on a test of 32, I would be 4/5 standard deviations, or about 0.8 standard deviations. I'm not quite 5 points above the mean on this one. Now, this curve here is very important. I need to tell you a few special properties about it. And jot this down. First thing you want to know is that it has reflective symmetry in the y-axis. Because of this is actually an even function, by the way. Reflects over the y-axis. The other thing is this graph actually goes from negative infinity over here to positive infinity. So they'll say that the domain is from negative infinity to positive infinity. Now, the graph, though, typically what they'll show is from -3 to +3, but do know it goes on forever. Third thing you want to know is the area under the curve. The area underneath this whole curve is equal to 1. And this is a very special feature of this curve and why we can use it for probability theory. If the area under this curve here is equal to 1, we could say that's 100% of the data underneath the curve. So what we do in lesson 11.2 is we find a particular z-score and we determine what the area is under the curve with that. Let's take a quick look in the next slide in terms of who uses normal distributions. Statistics is actually highly used in the business sector, and you're going to see maybe in product sales. If, for example, Best Buy was doing a graph of their sales products, they might see that there's this normal distribution. What you're looking for is that it has an even symmetry in it, and so it's nicely balanced. Economics uses normal distribution quite a bit in terms of wealth. They're going to say on average, most people are in the middle for wealth, so that's the middle. But then you're going to have the folks on the high end making a lot of money and the folks on the lower end not making as much money as the average. Another place they use these quite a bit, and you'll probably see it if you go to the doctor soon, is in weight and height distribution tables. When you go to the doctor, they measure and weigh you, and they actually compare you to a normal distribution. The women here are in the pink, and that's a normally distributed set of data, and the men are in the blue. And so the medical field will actually use this data quite a bit. Now, this right here is a very important table. You will find it in the very front page of your note packet, and you're going to want to reference this. If you need it for homework, you're going to want to reference this. If you need it for a worksheet, you'll reference it. And here's what it works. It is a table that tells you the area under the curve given a particular z-score. And what you want to look at is this right here. This is the first part of the z-score. So this is the ones and the tenth digit of the z-score. This right here is going to be the hundredth digit. So if I'm looking at it in terms of a number, that's this digit right here. So to find a z-score, for example, if we said we have a z-score of 2.5, what I would do is go to 2.5, which is right here, and it's really 2.5. It's 2.50, and the 0 is right here, and I would just look to see where they match up. If I go to this graph and I plot the z-score of 2.5, it's going to be probably roughly about right here. So what this table gives you is the area from that point all the way to the end of the graph. So again, if I had a z-score of 2.5, it means on average I deviate on the high end of some data. So if we do some test scores, it means I did actually really good in terms of the class average. I have 2.5 deviations above the class average on a test. What percent of people are below me? This would say 99.38% of the people are below my z-score, which is right here. Okay. Let's do some practice. The rest of the notes we just go through, how do you really use this normal distribution and use the table to find your answers. So let's go ahead and do that. All right, we talked about this a little bit, but let me tell you, what if the actual Chapter 9 test you just took, the average out of 39 points was 31? The standard deviation was 3 points. So again, on average, most people deviated either 3 points high or 3 points low. If you got on your test a 34, what's your z-score? So my z-score would be 34 minus 31 divided by 3, which is 3 divided by 3, or 1.0. Okay. Now where that shows up on a standard normal curve is look for 1.0. It's right there. So I would plot this line and say if I go to the table, the z-score table, it will tell me the area under the curve from 1.0 all the way back to the end of -3, really to negative infinity. Everyone else, that's the percent of people that did worse than me on the test. So go to the front note packet in your notes and look for 1.0, and you're going to see the number is 0.8413 on the table. Okay, that means the area under this curve is 84% of the graph. So 84% of the class did worse than me on the test. Well, folks, from that I could actually deduce what percent of people did better than me. Well, the special property is the area under this curve is 1. So take 1 minus this number, and I could deduce from this that about 15% of the class did better than me on the test. And that's how you would use a normal distribution. I'm going to walk through 4 different slides, and you can kind of pick and choose if you want to listen to some more, but they're just different examples on how to do this. Here we go. Consider a data set with a standard normal distribution. Find the probability that a randomly chosen observation is less than a 0.85 standard deviation above the mean. Okay. And then write the meaning of the result in part A. So they have for us, remember, this is a standard normal curve. The numbers on the bottom of this curve are the z-scores. So they're saying their z-score is less than or equal to 0.85. Now this table, notice right here, it tells you it's for the z-scores all less than A. So let's make that adjustment, right? I have too much information. I want the z-scores less than 0.85. So if you look in the picture, we want this much of the curve. Well, here's the one thing. Folks, this curve has perfect symmetry. It means this half of it, if the area of the whole curve is 1, this half has to be 0.5, right? So that means my answer has to be higher than 0.5. Fine. Go to this table, look for 0.85. Well, here's the 0.8. I need the 5, which is right there. See where it lines up. It lines up right here at 0.8023, which means the area under the curve from a z-score less than 0.85 is about 80.23% of the curve is in that area. Now this next slide, what you're going to want to be able to do is actually plot where this is on the curve. So here we go. There's 4 parts to this question. Pick and choose what you want to listen to. I'd listen to it all. Here we go. Find the probability that a randomly chosen observation from a standard normal distribution is in the given interval. They want the z-score to be between 0 and 0.85. Okay, well the z-score of 0 is right here. 0.85 was right here. Now, one of the objectives said sketch this on the graph, because if you sketch this on the graph, you guys, that's the area they want you to find. So here's what I would write. They want you to find, here's what you would do, the probability that the z-score is between 0 and 0.85. So that's the mathematical notation they'll use. And you just have to think about how to get it. Well, the table of data, again in the front pack of your notes, gives you the z-score. Look at the z-score, gives you the area from that z-score all the way to the end. Well, the problem we just did on the previous slide said this area was 0.8023. I just want the blue section. So what is it? Again, important to know, the area under a standard normal curve is 1. If you cut it directly in half, means this right here has to be 0.5. So you can easily back into the brown section there, take the 0.823, subtract the 0.5. Therefore, the area in the brown section has to be 0.3023, or 30.23% of the graph has a z-score from 0 to 0.85. It means they deviate above the average of the data I'm looking at. Okay, part B. What's the probability my z-score is greater than 0.85? So I would write this, probability my z-score is greater than 0.85. That's the question. Okay, this graph here is for z-score, so I'm going to find that z-score, which is right here, and draw a line. And the picture says they want z-scores greater than, so I'm going to color that in. That's what I need. Now, we have to recall, if I go look up 0.85 in that table of all those areas, it's going to give me this area. We know that that is 0.8023. How can you get that green section? Take 1 minus 0.8023, and the area under this curve has to be 0.1977. So this tail end is 19.77% of the curve. Now this one's interesting to look at. They want the z-score to be less than negative 1.73. So I'm just going to write that out. They want the probability that the z-score less than negative 1.73. Okay, put it on the graph. Negative 1.73 is roughly here. And this is what they want, the probability that it's right there. I need that little tail end. Okay, here's the problem. When you go to the probability table, there are no negative numbers. They're only positive. I cannot look up positive 1.73 and get the exact answer. Go to the probability table, look up 1.73, and if you look that up, you're going to see the area under the curve if it's 1.73. Let me just sketch that for you real quick. Here'd be your curve. If it was positive 1.73, that I can look up in the table, and it's going to have an area of 0.9582. Okay, so what I found in that little section here, I'm going to actually put on this graph. So that's a positive 1.73. Okay. This area, by the way, is the 0.9582. I have to get that little red tail. How can you do it? The key to these problems is there's perfect symmetry in this graph. So what you need to realize is this empty tail right here is the exact same as that tail. So what you can do to find the red tail is take the area that I did in the brown, do 1 minus that. If I do 1 minus 0.9582, I'm going to get this little green tail. And that's going to give me 0.0418. Well, you guys, that green tail is the reflection of the red tail. So that means the area of the red tail has to be the 0.0418, or 4.18% of the graph sits in that red tail. Okay, let's look at this one. What's the probability that the z-score is greater than negative 1.73? Okay, first thing I do is I sketch the standard normal curve. I realize negative 1.73 again is about right here. And I'll jot it down. And they want greater than. So I'll actually do this. They want me to find this area here. Well, do I have to do anything special? The nice thing is I already did part C, and I found that the area of this tail was 0.0418. Well, folks, the area of that red section is just 1 minus that. The area of that red section is 0.9582. Okay? And that's the answer to this problem. Now, there's another thing to look at, though. The red section here on this curve, if you notice, I'm going to go back up to the example C. If you notice here, this right here that I'm highlighting in the yellow is the exact same thing as this part of the curve. It's been flipped over the y-axis. So if you can notice that this area here is the same as this area here, that symmetry is going to happen. And it's going to happen a lot with this curve because that's how it works. It has this wonderful symmetry to it. Okay, this is the last example, and listen to this one. About what percent of the data in a standard normal distribution are within 1 standard deviation of the mean? So if you look at the graph, they've computed the z-score already. Okay, they have a z-score of 1 to negative 1. So they want us to find the probability that the z-score is between negative 1 and 1. Okay, that's what the math notation would look like. Here's what the graph looks like. And figure it out. There's many ways to do this. Here's one way. If I go to the table on z-scores and look up the area under the curve, if I look up 1.00, you're going to see that the area under the curve for 1.0 is 0.8413. It gives me this all the way to the tail end. So that's 0.8413. Well, there's a couple things you can do. Here's the first thing you could do. You could realize that half of the curve is right here. And you could take the 0.8413 and subtract out 0.5. Okay. If I do that, I'm going to get 0.3413. That means this right here is 34.13% of the graph. Well, what do we know about this red section and this brown section? They're perfectly symmetric. They're reflections of each other. So just take this number here and double it or times it by 2. The area under this curve is 0.6826, or 68.26% of the data sits 1 standard deviation above or below the mean, which is a very important thing we're going to use later on in the chapter. Now, another thing you could do, I won't talk through it in detail, but if you wanted to solve this, you could have, again, found the area of the 0.8413 and then just subtracted out this tail. You could figure out that tail amount and subtract it from it, and you would be left with the red and the brown sector. So just another approach to the problem. Now, for the homework, I would say go ahead and skip number 15. Okay, so skip 15. And then I'll give you some insight on 16. What you need to do on that is you need to compute the z-score first. You need to find the z-score yourself and then use the curve to find the answer. The other problems, they give you the z-scores and you have to find the area under the curve. And sometimes they'll give you the area under the curve and you have to find the z-score. So good luck on the homework. Let me know what questions you have.